Good morning, this is Rachana, Assistant Professor of Mathematics, Institute of Aeronautical Engineering. Today, I am going to discuss about Lagrange's mean value theorem problems. In the last session, we have discussed how the function satisfies the continuous property, differentiable property, and f dash of c equal to f of b minus f of a by b minus a. So, how the function satisfies all these conditions. Now today I want to discuss about inequalities, how we can check by using Lagrange's mean value theorem and how we can prove the inequalities. So here we have one inequality, that is b minus a by 1 plus b square less than tan inverse b minus tan inverse a less than b minus a by 1 plus a square using Lagrange's mean value theorem. So by using the condition, we can find these two deductions also. First, take function. So here in the previous session, directly given f of x and intervals. But here we have f of x. What is f of x here? Tan inverse x. So f of x is here tan inverse of x, and the given interval is general interval we have to consider. That is AB. First of all, we have to prove this inequality. So that's why f of x equal to tan inverse x in a comma b for 0 less than a less than b less than 1. So here f of x is continuous in closed interval ab and differentiable in open interval ab. Why which is continuous? In between ab, all the points are positive points. Why? Because here we have the condition a and b are lies 0 and 1 only. So substitute any point in between 0 and 1 will get finite limit. So for f of x equal to tan inverse of x is continuous. Why? Because here 0 and 1 in between there is no point value. So at any point there is no negative point, and at any point will get finite limit value. So f of x equal to tan inverse of x. So in closed interval a comma b. So since f of x is continuous, now go for derivative. Already we know that tan inverse of x is differentiable function. How which is differentiable? So we have f of x is tan inverse of x and f dash of x is 1 by 1 plus x square. So f of x is differentiable also. So here we have a general interval, that is a comma b. Both a comma b are positive points. So we'll get the f of x is differentiable in the interval open a comma b. So here two conditions are satisfied. So we can apply Lagrange's mean value theorem. So then there exists a point c open interval a comma b such that f dash of c equal to f of b minus f of a by b minus a. This is the condition. So by using this condition, first we have to prove this inequality. So what is the first intention? Consider the function f of x. Here we have tan inverse of b minus tan inverse of a. So definitely the function is in terms of tan inverse of x. That's why I consider here f of x equal to tan inverse of x. So check that the function is continuous or not and differentiable or not. Continuous in closed interval a comma b, differentiable in open interval a comma b. So then we have a condition in Lagrange's mean value theorem. What is that condition? If two conditions are satisfied, then there exists a point c in open interval a comma b such that f dash of c equal to f of b minus f of a by b minus a. What is f of b? F of b is nothing but tan inverse of b, and f of a is nothing but tan inverse of a divided by b minus a. So this is f dash of c, and here we have to remember one thing. So here we can apply the Lagrange's mean value theorem, and c must be lies in between a and b. Nothing but a less than c less than b condition must be satisfied. So here we have to do, by using Lagrange's mean value theorem, we have to prove these inequalities. So definitely C must be lies in between A and B. Then only we consider A less than, C less than, b. So here f dash of x is 1 by 1 plus x square. Now we want f dash of c. F dash of c is nothing but replace in place of x c. That is 1 by 1 plus c square. So what is Lagrange's mean value theorem? Then there exists a point c such that a less than c less than b. What is the meaning of these? C implies c belongs to open interval a comma b. C belongs to a comma b means c lies between a and b. So then there exists a point c in between a b such that a less than c less than b. So what is the condition? We have f dash of c equal to f of b minus f of a by b minus a is the condition. What is f dash of c? 1 by 1 plus c square. So f dash of c is left hand side 1 by 1 plus c square, and right hand side f of b. What is f of b? Tan inverse of b minus tan inverse of a divided by b minus a. F of b minus f of a by b minus a. Take this as some equation 1. This we will use later. So take the condition. Which condition is here? A less than c less than b. So here our target is make this c to 1 by 1 plus c square form. So for that, first take the square. So I am taking both sides square. A square less than c square less than b square. Next add both the sides 1. 1 plus a square less than 1 plus c square less than 1 plus b square. This is the step. 1 plus a square less than 1 plus c square less than 1 plus b square. Next, which one we have to take? 1 by 1 plus c square term we want. So that's why here we have only 1 plus c square. How will get? Take 1 by 1 plus c square. So if we take 1 by 1 plus a square less than become greater than. 1 plus c square become 1 by 1 plus c square greater than 1 by 1 plus b square. Now substitute 1 by 1 plus c square value. What is 1 by 1 plus c square value? Tan inverse of b minus tan inverse of a divided by b minus a. So in place of 1 by 1 plus c square, take the value. So from equations 1 and 2, we have left hand side as it is 1 by 1 plus a square. In between only we consider tan inverse of b minus tan inverse of a by b minus a greater than 1 by 1 plus b square, or take the positions greater than become less than. That is nothing but, and b minus a also I am taking to the both the sides. So nothing but we have b minus a by 1 plus a square less than. I am taking first term, or tan inverse of b minus tan inverse of a less than b minus a by 1 plus b square. So hence the result. Now by using this, we have to take the deductions also. So for what values of a and b, we'll get the two inequalities. So for the first one, I am substituting b equal to 4 by 3 and a equal to 1. We have to choose a and b for the given inequalities, for the given deductions. Here we got the value, that is b minus a by 1 plus b square less than tan inverse of b minus tan inverse of a less than b minus a by 1 plus a square. This we got it. Replace a and b, give some values of a and b. This we have to choose. Then you will get the deduction. So if we substitute b equal to 4 by 3 and a equal to 1, what happened here? 4 by 3 minus 1 by 1 plus 16 by 9 less than tan inverse of b minus tan inverse of a less than b minus a by 1 plus a square. So simplify this. Take the LCM here. 4 minus 3 by 3 and the denominator 9 plus 16, 25 by 9 less than tan inverse of 4 by 3 minus tan inverse of 1. When in tan 1, tan inverse of 1, tan pi by 4 is 1. So we have tan inverse of 1, nothing but tan inverse of, in tan we have tan pi by 4 is 1. So both tan inverse cancel. So we have here 1. So 4 by 3 minus 1 by 1 plus square, 4 minus 3 by 25 by 9. Tan inverse of 4 by 3 minus pi by 4 from this, less than b minus a by 1 plus a square, b minus a, 4 by 3 minus 1, nothing but 4 minus 3 by 1 plus a square, nothing but 1 plus 1, 2, so 3 by 2. Now simplify that, you will get 3 by 25 plus pi by 4 less than tan inverse of 4 by 3. I am taking this pi by 4 both the sides, nothing but, or we can say like this also, adding both the sides pi by 4. If we add both the sides pi by 4, here pi by 4 plus pi by 4 and here minus pi by 4 cancel. So 3 by 25 plus pi by 4 less than tan inverse of 4 by 3 less than pi by 4 plus 1 by 6. This is the first inequality. Similarly, taking b equal to 2 and a equal to 1. These two assumptions are based on the given directions. We have to check that for what values of a and b will get the direction. We have to take and we have to choose those a and b values. So taking b equal to 2 and a equal to 1, we get b minus a by 1 plus b square. Substitute in this inequality. Then you will get the direction. So b minus a, 2 minus 1 by 1 plus b square, nothing but 1 plus 4, less than tan inverse of b minus tan inverse of a, less than b minus a by 1 plus a square. So 1 by 5, 2 minus 1 is 1 by 5 less than tan inverse of 2 minus, again tan inverse of 1 is nothing but pi by 4 less than 2 minus 1 is nothing but 1, 1 plus 1 square is 2. So simplify that, we'll get, and pi by 4, adding both the sides pi by 4. So 1 by 5 plus pi by 4 less than tan inverse of 2 less than 2 plus pi by 4. Or we can take one more step, take the LCM here, 4 plus 5 pi by 20, tan inverse of 2, and here 2 plus pi by 4. So based on given direction, we will simplify. So these are the inequalities using Lagrange's mean value theorem. And this is one more case. Show that for any x greater than 0. What is the meaning of x greater than 0? Here given interval is 0, x only. So there is no negative values. Function is 1 plus x less than e power x less than 1 plus x into e power x. Using Lagrange's mean value theorem, we have to prove this inequality. How we can prove this inequality? First of all, we have to consider the function f of x. What is the function f of x? Exponential term, e power x. Interval is, for the given condition, we have to take the interval. Here interval is 0, x. So let f of x equal to e power x and defined on which interval? 0, x. Then f of x is continuous and differentiable. Why which is continuous and differentiable? The given interval is anyway positive, 0, x. F of x is here e power x. E power x is continuous. Why? Substitute any point in this will get finite limit. So that's why the function f of x is continuous in which interval? Open interval 0, x, and go for the differentiable condition. So this is f of x, and already we know derivative of f of x is e power x, which in between 0, pi. F of x is e power x, which belongs to 0, pi. So both the conditions of Lagrange mean value theorem satisfies for the function f of x in the interval 0, x. So if two conditions are satisfied by Lagrange's mean value theorem, there exists at least one number, at least one point C, open interval 0, x, such that what is the condition? F dash of c equal to f of b minus f of a by b minus a. This is the condition. So what is a and b here? A equal to 0, b equal to x. First take that f dash of c. So f of x is nothing but e power x, f of 0. E power 0 already we know. E power 0 value is 1. So e power x minus e power 0 by x minus 0. That is the formula b minus a. And the right hand side here we have f dash of x. E power x derivative again e power x. So here we have f dash of c. That's why replace in place of x c. Nothing but e power c. So e power c equal to e power x minus 1 by x. This is the sum equation 1. Now take the condition. Which condition? Here c must be lies in between a and b. A less than c less than b. So c must be lies between a and b. A is here 0, b is here x. So that's why I'm writing here 0 less than c less than x. So here what is c? We have to take for equation 1, take the exponentials in the 3 terms. So e power 0 less than e power c less than e power x. To get the inequality, we have to take e power c term. E power c we know. So that's why c I want to change e power c. So that's why I'm taking e power 0 less than exponential I'm adding. So e power 0 less than e power c less than e power x. E power x is definitely is increasing function. So e power 0 already we know 1. Now what is e power c from this? E power c is nothing but e power x minus 1 by x. So e power x minus 1 by x less than e power x. Now take x both the sides. 1 into x e power x minus 1 less than x into e power x. Now I'm removing minus 1 also from this. So that's why I'm adding both the sides plus 1. So x plus 1 less than e power x less than 1 plus x into e power x. So what we have to prove actually 1 plus x less than e power x less than 1 plus x into e power x. So this we proved as it is. So whatever the inequality and whatever the given conditions, use the Lagrange's mean value theorem. First we have to consider f of x. So for this inequality, we have to choose f of x is definitely in between function. So here the in between function is exponential function. So take f of x is e power x. And for the given condition, take the interval also. Here for any 0 less than x greater than 0. Nothing but the interval must be 0 comma x. So by using this function and inequality interval, we have to take the Lagrange's mean value theorem conditions. First condition is continuous. Whether the function is continuous or not, we have to check. And the second condition, whether the function is differentiable or not. If two conditions are satisfied by Lagrange's mean value theorem, we can say there exists a real number. Here 0 comma x, both the points are real. In between also we have only real numbers. So if two conditions are satisfied, first condition is continuous and the second condition is differentiables. If two conditions are satisfied for the given function f of x, then there exists a point C which lies between open interval AB. In this problem, we consider 0 and x are upper and lower limits, interval limits. So then there exists a point C in between AB such that what is the condition? F dash of C equal to f of B minus f of A by B minus A. B is nothing but x, A is nothing but 0. Substitute in place of B and A, f of x minus f of 0 by x minus 0 equal to f dash of C. E power x minus e power 0 by x minus 0. So e power c as it is e power x minus 1 by x. Take this as some equation 1. So here we should remember one thing, c must lies between open interval 0 comma x. So that's why I'm writing here 0 less than c less than x. Always c must be lies in between a and b. A less than c less than b. So from the first equation e power c, I'm taking both sides exponentials. So e power 0 less than e power c less than e power x. So e power 0 is 1, e power c is what? E power x minus 1 by x and less than e power x. So e power c substituting using equation 1. So I'm taking e power x minus 1 by x less than e power x here. So x multiply both the sides. Then x cancel here and we'll get here x less than e power x minus 1 less than x into e power x. So in between we have minus 1 also. In the given inequality, we have to prove e power x only in between. So that's why I am removing minus 1 here. How we can remove minus 1? Adding both sides plus 1. So if we take plus 1, here we have 1 plus x less than e power x less than 1 plus x into e power x. So now the inequality is proved by using Lagrange's mean value theorem. So all these inequalities are important and very simple. So first we have to remember that whether which one is the function and which one is the interval. Only that we have to check. If the function and interval is there and everything is same, we can prove very easily by taking continuous property, differentiable property and the condition. What is the condition? F dash of c equal to f of b minus f of a by b minus a condition. So like this, we have to prove the given inequality by using Lagrange's mean value theorem. Hope you all understood this session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.